Today we are going to study about the different types of chemical reactions. The first type of chemical reaction we are planning to study is called synthesis reaction. In synthesis reaction, according to the Ontario textbooks, you would find that if the reactants are elements, then the reaction is considered to be a synthesis reaction. But generally, I tend to believe that if you make a new substance from a combination of reactants, then we are synthesizing something new. For example, polymers, polyvinyl chloride, polystyrene, polyethylene. All of these compounds are not made from single elements, they are made from monomers, which are compounds. Therefore, there is a slight distinction in the usage of the language synthesis reaction. But for the sake of simplicity, I would go, if the reactants are elements, then the reaction can be considered as a synthesis reaction. Here, the formation of waters can be taken as an example. The reactants are both gases. They are both elements. They change into a new substance, which is a liquid, and the product is a compound. Here is an animation of the reaction. The yellow atoms represent hydrogen and the blue represents oxygen. Similar kind of elements in the uncombined state. Once they change into a new product, both of these interact and change into two molecules of water. Here you have a compound. They're no more identical. They are made from different atoms. That's the whole idea. The second type of reaction that we're going to look at is called a single displacement reaction, sometimes referred to as a single replacement reaction. Here, if an element, it could be a metal or a non-metal, reacts with an ionic compound, then if a chemical reaction takes place, the metal can displace the metal in the ionic compound. That's what it means here. Which also implies the element that we have taken, the metal that we have taken, is less reactive than the metal in the compound. There will be no chemical reaction. Here is an example. Copper, solid in the elemental state, is reacting with silver nitrate. There should have been a subscript AQ indicating that silver nitrate was soluble in water. The products formed will be silver and copper 2 nitrate. Obviously, a white precipitate or grayish precipitate of silver will be formed in this reaction, and the liquid that is formed or that is present there turns blue due to the presence of copper ions. From experience, we know that this reaction does take place, and therefore you can also infer or conclude that copper is more reactive than silver. If that was not the case, the reaction would not have taken place, which means if I replace copper with gold, the metal gold, and if I put a gold chain in silver nitrate solution, nothing is going to happen. But if I put a copper penny in silver nitrate, I can actually obtain silver, and the copper will dissolve. This reaction can be used to identify which elements are more reactive than other elements, and we can actually make a series called the activity series or the reactivity series and arrange the elements in the increasing or decreasing order of their chemical reactivity. Here is an animation of between copper and silver nitrate. Silver nitrate is dissolved in water. Obviously, they will not be connected in water because they will break up. They will undergo hydration. Here, just for the sake of showing what would have happened if the chemical reaction took place, you'll find that the copper ions associate itself with the nitrate to form copper nitrate, and the silver atoms are displaced. it gives you metallic silver. So if you want to recover silver from a silver salt solution, all you have to do is add some copper. So this is a metallurgical process too, obtaining metals by single displacement reaction. It is also used in certain industries to generate metals and close the cracks in large structures of iron using the thermite process. That will be an interesting process to read about. Double displacement reaction, also called double replacement reaction. In this reaction, both of the reactants are compounds, and there will be a chemical reaction between them, and if that's the case, a new product will be formed, usually a precipitate. The precipitate is the ionic compound which has low solubility, which means if the compound formed has a higher solubility, we will not see a precipitate, and typically or potentially we would say that there is no chemical reaction taking place there. Ions that remain in solution are called spectator ions. Here is an animation. I have lead to nitrate and copper to chloride. Calcium to chloride. Both have divalent metal ions, and nitrate and chloride both have a valency of -1. If there is a chemical reaction, lead will change into lead chloride and calcium will change into calcium nitrate. Between calcium nitrate and lead chloride has got low solubility, so usually you will get a white precipitate of lead chloride. And calcium nitrate that is formed will not precipitate. It will remain in solution. Therefore, calcium and nitrate ions will be the spectator ions in this reaction. Lead chloride, the solid. That's it for now. Hope this could give you some insight into the types of reaction. There are a couple of other types of reactions too, which is not included here. One of them is called a decomposition reaction, where a single compound breaks up to give you more than one element. That is just the opposite of a synthesis reaction. For example, if you consider calcium carbonate, if you heat it, it changes into calcium oxide and carbon dioxide, breaking up. That's a typical example of a decomposition reaction. That's it for now. Please comment and rate this video. If you have any questions, please do post it.